everyone. In this video, let us discuss what are remains of a matrix in place program. Okay. Observe input and output specification. So first of all, we need to take row and column size. Next of all, we should take values into matrix, and so we should print what remains of this. Okay. So if you look at this matrix in water, it exactly looks like this. Okay. So that is 4, 5, 6, and 1, 2, 3. So means this is nothing but reversing the rows. Okay. Uh, so first of all, I'll explain how to reverse the rows of matrix. Okay. Normally, afterwards, let us discuss in place. Okay. Observe. So first of all, let us take rows and columns input. So that is a map of int comma input function dot split. Next. So after that, let us collect values into the matrix. Okay. So first of all, here I am taking some empty array. Okay. So next, so in each and every row you observe some one list, right? Okay. So just with the help of single loop, we can take the input of 2D matrix here. Okay. So let us see that I am running the loop for only rows here. Okay. Columns loop not required. In each and every row, you are observing some list, right? List input, list of map of int comma input function dot split. Okay. What you need to do, whatever the lists we are collecting here, all these we should keep it into the main array so that nested list is going to be created now. Okay. So observe this how we are performing that process. Into the array, I'm adding all the lists, whatever I am getting in each and every row with the help of append method. Okay. Next. So here with this input part completed. So first let us normally print. So 2D array values now in matrix form. So that is for I in range of R and for J in range of C. I loop I am running for rows, J loop for columns. Next. So array values, matrix values I am printing here in between. So the values we need to add space here, separator constant. So I'm changing to end constant. I'm changing to space. And after completion of each and every row, we should move cursor to the next line. Okay. For that sake, I'm adding empty print statement here. Automatically end constant backslash and adds. Okay. It's not required to take this. So let us check whether it works or not. First of all, I'm entering row and column size. Next of all, matrix values. You can check here. So the matrix values are printing. Okay. So the first thing is just by reversing the loop, reversing the rows, okay, we can print the what remains of a matrix. How we can reverse the rows loop here? As usual, index starts from 0 and 0, ends with row size -1 and column size -1. So here I am running the rows loop from row -1 to 0. For running up to 0, we should take stop value -1 and step value -1. Okay, let us check now. So whether we get what remains of a matrix or not. Yes, we are getting. There is no problem in it. So, but the thing is here, just we are printing the matrix values in reverse direction. That's it. We are not changing the original matrix values to the what remains form. Okay. So that is what required for designing the next upcoming programs. Okay. You are going to understood that. For rotating matrix 90 degrees clockwise and anti-clockwise in some platforms like lead code, gigs for gigs. they asked us to do the operations in place. Okay, at that time, so this program is required. Okay, that's why I'm explaining so the in place program now. Okay, so have a look. So we need to print matrix values as usually, but although we go for printing as usually, it should print in what remains form. Means in between input and output part, we should add the code. So for reversing the rows of matrix. Okay. So whenever you see in place so operations, okay, uh, we need to perform some swap operations here. Okay. Already in arrays program also you observed 1D arrays. Beginning and so ending position values interchanged with two-pointer approach. Likewise, here also we follow the same. So for performing the swap of beginning rows with the ending rows, okay. So all of you have a look at this. So I'll take some. So big one. So here, so the thing is on reversing. So this what we are going to get 4, 6, 2 next 7, 8, 9 next 4, 5, 6 and so 1, 2, 3. So means you can observe one thing here. So the last row and so the beginning rows are swapped here. And next to that, you can observe one more thing here. So intermediate rows are swapped here. Okay. So based on that, it is clear that we need to swap beginning rows, so position values with the ending row position values. Okay. So first, let us take the positions. Positions plays very key role here. With the help of positions, we can easily design the logic. Okay. So observe positions 0, 0, 0, 0 position has to be swapped with so 3, 0 position. Next 0, 1 position value has to be swapped with third 3, 1 position. 0, 2 position has to be swapped with 3, 2 positions. Okay. Observe here 0, 0 with 3, 0, 0, 1 with 3, 1, 0, 2 with 3, 2. If you observe so carefully, you can understand one thing here. So the first subscript, so values are so fixed here in both these two positions. So here it's 0, okay, and here you can observe that it's 3. So regularly how we start, so two-pointer approach you all know. So initially we take start to 0 and end to size minus 1, that is row minus 1 here. So you'll get row value is 3, 4 here, 4 minus 1, 3. So means it's clearly proved that so for getting so here you should not go for using so these values directly because it won't works for remaining intermediate rows. Okay. So our program should work for all rows, right? Okay. That's why instead of values, we should design program for variables. Variables takes different values different times and it works. Okay. So here, so for getting so 3, you should use it. Indirectly, we are inducing so the 3 only. Okay. And what values you should take here in the second subscript you should understood. Okay. Observe here. So column subscript values you can understood one thing. So here also you can observe 1 0 1 2 and here also you can observe 0 1 2. And what are these? These are nothing but columns, right? 0 1 0 column, first column and second column, second subscript, right? So means we should run the loop. So four columns here, okay? So 1 minute. So after this, you all know this condition. So frequently we use it, okay? So next to this, we should use the columns loop here, okay? See, if it is square matrix, there is no problem of thinking about this. What we should use here, R and C, okay? So in both the locations, you can use N. but it's rectangular matrix, right? So that's why I'm using this. Next, so what are the positions we are generating here with this loop? We need to substitute here, okay? So that is start of I position values has to be swapped with so end of I position values, okay? Let us take so this one to here. So after completion of swap, what we need to do? Next, what position values we need to so swap? 1 0 with so 2 0, 1 1 with 2 1. Next, so 1 2 with 2 2. So means here you can observe the starting position value is updated to 1 and ending position value is updated to 2. Okay. So means after completion of the loop, so we need to update start and so the end to the previous location. Start to the next location and end to the previous location. That's it. With the help of so this program, so we can finish so what remains of a matrix. With the help of if you make small changes for this, we can finish the next program called mirror image of a matrix. Okay. So let us see that one now. So let us execute whether it works or not. Okay. So start and end is equals to 0 comma r minus 1 while start less than end. Loop I'm generating so for columns. Next, so array of start of I position values has to be swapped with end of I position values. Array of end of I, comma, array of start of I. After this start, we need to update by 1, increment by 1, and end we should update to the previous location. After completion of this, if you go for printing, so the 2D matrix value is normally, it prints, so in what remains form, you can check now. So 2, 3, 1, 2, 3, and 4, 5, 6. Let's check. So it's working here. Okay, so I hope you understood. So how to print what remains of a matrix in place here. Okay, how this knowledge helps you to design upcoming programs you are going to observe that. Okay, so that's it. So for this video, let us meet in the next video. Thank you. Thank you.